everyone, this is the 8th video of Chapter 3, Solving Systems of Equation Algebraically. In this lesson, you will solve a system of equations using the substitution method. Last lesson was focusing on the graph, where this time you will be using substitution. An algebraic model that can be used to find the exact solution of system of equations are called substitution. Substitution is an algebraic model that can be used to find the exact solution of a system of equations. Another word of substitution are plug in, replace, switch, or change. Here's an example number 1. Solve the system of equations algebraically. Keep in mind the system means you will have 2 or more equations. And as you see, I have y is equal to x minus 3 and y is equal to 2x. In order to use the substitution method, you will be setting up at least one equation has to be y equals or x is equal to. In this case, both of the equations start with y is equal to, so this one should be done already. And then you're going to substitute one equation to the other. For example, they are saying y is equal to x minus 3, where the second one is saying also y is equal to 2x. Since both are saying the y is x minus 3 or 2x, I'm going to replace y with the 2x in here. So this is what it will look like. Instead of y, if I replace with 2x, 2x is equal to x minus 3. The reason we are trying to replace with another variable is because when you have the same variable on each side, you can solve to find what the x is equal to. And then now you're going to solve for either x or y depending on what your variable is. In this case, we're solving for x. So if I draw the line, it doesn't matter which side you choose, but if I want to choose this side to have all the x's, this x right here needs to be removed by subtracting x from both sides. And then 2x minus x will become x. X minus x will be 0, and then you will just bring down negative 3. So I know x is equal to negative 3. Then the next one is you need to replace this one more time back into your equation. So you're going to substitute one more time by using what you found from number 3. So in here, since I know that x is equal to negative 3, you can either plug on the first equation or the second equation, because the answer has to be same as they are both written as y. If I plug x is negative 3 on here, you will have y is equal to, instead of x, I'm putting negative 3 and then minus 3. That makes y is equal to negative 6. Just to show you that if I plug negative 3 on this equation, it should be the same answer. So the second one was saying y is equal to 2 times x, where x is negative 3. And if I solve this, y is equal to 2 times negative 3, I get negative 6. So that's how I know that it doesn't really matter which one you choose from. The last step in here will be how you write the answer. When you write the answer of system of equations, it always has to be in the form of x comma y. You need to have both variable in number. So some people write just x is equal to negative 3 comma y is equal to negative 6. That's totally fine as long as you're showing me both. But normally what I do is I just keep x is negative 3 and y is negative 6, and this is going to be your solution of number 1. Couple more example in here. If I had y is equal to x plus 4 and y is equal to 2, again, you're going to set y is equal to or x is equal to, where in this case they are both y equal to. That's fine. The second step was you're now going to substitute. So pick an equation whichever you want to. Since they're saying y is equal to 2 up here, where I also have another y in here. So if I plug this 2 into this y, this becomes 2 equals, that's your y that I replaced with, x plus 4. If I solve this, I'm going to draw the line. And since x is already on this side, let me get rid of this 4 by subtracting 4 on both sides. 2 minus 4 is negative 2. X, bring it down. 4 minus 4 is 0. So it tells me x is equal to negative 2. Fourth step was for you to substitute from what you found on step 3. However, on this one, they already told you that y is equal to 2. So you could use it right away, or if you just want to plug back in, then if this was negative 2, y is equal to negative 2 plus 4, which will make you, again, just 2. So that's how I know y is equal to 2 either way. When you write the answer, it always has to be in the form where you can give me x and y at the same time. So here I'm going to write x is negative 2, y is positive 2, and that's going to be my solution of part A. For part B, similarly, if I plug 3x is going to be your y. Since y is 3x, 3x is equal to x minus 6. After you substitute, you're now going to solve it. If I want to solve this, since I have 3x and x on both sides, you can choose either way, but if I choose this side, I'm going to subtract x on both sides, so that way all the x's are on the left. 3x minus x is 2x, x minus x is 0, and all I get is negative 6. 2 and x has multiplication in between, so in order to get rid of the 2, you have to divide by 2 on both sides, and x becomes negative 3. So that was up to step 3. Now the step 4 is for you to substitute this value again into your either equations. I prefer to plug it into the shorter one, so that way it'll be less steps. If I plug into y is equal to 3x, this will look like y is equal to 3 times x was negative 3. This will make negative 9 when you multiply them. So that's how I know when you write the answer, x is negative 3, y is negative 9, and that is going to be my solution. You can always double check to see if it's true. If I plug negative 3 in here, negative 3 minus 6, it does give you negative 9. Also, this coordinate has to work for the second equation. If I plug x as negative 3, 3 times negative 3 will give you negative 9. So that's how I know this coordinate satisfies both equations. Sometimes one or both equations are written in standard form. When solving a system by substitution, one of the equations should be solved for either x or y. So this was saying that, remember that my first step was always you have to have y is equal to or x is equal to. When you are given with the standard form was ax plus by is equal to c. This form does not look like y equals to or x equals to. Here's problem number 2. Solve the system of equations algebraically. So again, like I said, this first one right here is slope-intercept form, where you start with y equal to. However, the second equation is standard form, where it's not written as y equal to. In this case, since you already have y is equal to in one of the equations, this should be done easily. We're just going to move on to the second step, where it's going to be substitution. So unlike the other problem, the main difference is when you had a choice to which one you can choose from, this one, the best option right now will be just using this one to substitute. So here what they're saying is y is equal to 3x plus 8, where I also have y on here. What you're going to do is you're going to substitute this whole term into your y. And if I rewrite this, so the 8x plus 4 and the y, they are in multiplication. I'm going to multiply by the whole thing, 3x plus 8 from my first equation, that has to equal to 12. I'm going to simplify this by distributing. If I distribute, well, this one, 8x, just bring it down, plus 4 times 3x, 12x, plus 4 times 8 is 32, that's equal to 12. 8x plus 12x, they are like terms. If I add them, I get 20x. And since I have 32 over here, I need to get rid of this to the other side. And the 32, just bring it down and you will get 12. Now the next step is continue to solve to find your variable. So in this case, I'm solving for x. So if I draw the line, since x is already here, I want to get rid of this 32 by subtracting. 32 minus 32 will be gone. 20x just brings it down. 12 minus 32 will become negative 20. If I divide by 20 on both sides, x becomes negative 1. So now that you know one part of the answer, that x is negative 1, I still need to find what happens to your y value. Now that you found the x, you can plug it in either of the equations, so that's up to you. The fourth step was substitute what you found in number 3. Now if I substitute this, I believe the first equation will be easier for me to figure out what the y is. Y is equal to 3 times, you will have negative 1 for your x and plus 8. Simplifying this, 3 times negative 1 is negative 3, and plus 8 will give you positive 5. So that's how I know y is 5. And when you write the answer, you need to always have x comma y. So here is the negative 1 comma 5, and that's my answer. Number 3, a total of 75 cookies and cakes were donated for a bake sale to raise money for the football team. There were 4 times as many cookies donated as cakes. Write system of equations to represent this situation. This is similar to last lesson when we were supposed to write the equation from the given situation. The system, again, means you have 2 or more. So when I say system of equations, you're saying two or more equations. At this level, you will only deal with up to two equations. So the first equation that I can come up with is the total of 75 cookies and cakes. Let's say x is going to be your cookies and your y is going to be cakes. If I do so, when you add them together, the total should be 75. Now the second equation that I can come up with is right here. In this sentence, they're saying there were 4 times as many cookies donated as cakes. So the cookies, the x and y had a relationship and that there were 4 times more cookies than cakes. If I want to set it as an equation, since this one already has more, I'm going to multiply 4 onto your y. So that way, since x already has more, if I multiply 4 to the cakes, the amount should be equal. Now we're going to solve it by setting y is equal to or x is equal to. In this case, the first one doesn't look like a slope-intercept form. However, the second one, even though it's not slope-intercept form, it's saying x is equal to something. So this one is already done, and I can just use the second equation to substitute. So since x is equal to 4y, if I substitute this on here, 4y plus y is equal to 75. And you're just going to solve this. 4y plus y is 5y is equal to 75. Since they have multiplication in between, divide by 5 on both sides. Y is equal to 15. So that's how I know when I write the answer at the end. My cakes will be 15. And then continuing, I still need to substitute one more time to find the missing x value. So then it looks like the second equation is simpler than the first one. I'm going to plug 15 in this y. If I do so, x is equal to 4 times 15, I will get 60. And that's how I know there are 60 cookies. So let's double check. 60 plus 15 is 75 total. And when I'm looking at it, I do have 4 times more cookies than cakes because 4 times 15 should get you 60. And here, my answer will be, if you write in coordinates, I will have 60, 15. Since this is a real life situation, this one right here could be also my solution set. I accidentally did number 4 as well as number 3. So when number 4 was asking, solve the system in number 3 algebraically and interpret the solution, it's right here. So x was representing the cookies where you had 60 total. And the y was cakes that you have 15. The last problem in here, Mr. Thomas cooked 45 hamburgers and hot dogs at a cookout. He cooked twice as many hot dogs as hamburgers. Part E, write a system of equations to represent this situation. And part F, solve the system algebraically and interpret the solution. Again, when they're asking you to write system of equations, I need to set up two equations. The first one is if I have x as hamburgers and y as hot dogs, when I add them total, it will become 45. The second part in here is saying, right here, he cooked twice as many hot dogs as hamburgers. So if I want to find the relationship between x and y, they were saying there are twice more hot dogs than hamburgers. Since hot dogs were y, if I want to set them to be equal to, this one has already more, so I'm going to multiply by 2 to the x, so that way they will be equal amount. Now that we're going to substitute, since this one is a standard form, that doesn't look like y is equal to or x is equal to. For the second one, if I switch the order, this is saying y is equal to 2x. So what I can do is I can plug this 2x into your y because they are saying y is 2x. If I do so, this becomes x plus, I will have 2x is equal to 45. Now you're solving this, x plus 2x is equal to 3x, that's equal to 45. And x becomes, if you divide by 3 on both sides, I get 15. So that's going to be your hamburgers. Now you're going to plug this value one more time into either of the equations. If I plug 15 in here, this becomes 2 times 15 is equal to y, where 2 times 15 is 30, and that's your y value. I could also do the same if I knew that x was 15 on here. 15 plus what would give you 45? The answer is 30 as well. So it shouldn't really matter which one you pick from. Now, when I say the hot dogs are 30, let's see if it makes sense. There were supposed to be 45 total. So 15 plus 30, they do make 45. They were saying twice as many hot dogs as hamburgers. So as you see, I do have twice more hot dogs than hamburgers because 15 times 2 is 30. To interpret the solution, you can actually just use this as your final answer. This is the end of the lesson. Thanks for learning with me. If you have any questions, please leave a comment.